area of the shaded region. So first off, we have a circle. So quite simply, area equals pi r squared. Okay, so we are going to look at what we need here. We have the diameter of 6, so we're going to use 3. So area equals pi 3 squared, or 9. So if it wants the exact answer, the answer is 9 pi square centimeters. That's the exact answer. If we multiply by pi, 9 times the pi key, we get 28.27 centimeters squared. And again, if you use 3.14, slightly different there. But since computer seems to want the pi key, probably good practice just to stick with that. Okay, now what we have here is a rectangle and a circle. Well, what we're going to have to do here is find the area of both and subtract the circle out, because we're not wanting that region. So we're first going to find the area of the rectangle. And that's just simply length times width. So that's going to be 15 times 22. And that's 330. I'm going to circle that because I'm going to need that for later. Now, I don't care about the 22 for the circle because the circle, that is bigger than the circle. But if this is the length, or the width, whatever you want to call it, then it's also the diameter. So that means the radius is 7.5. So the area of the circle is going to be pi r squared. So 7.5 squared times pi, and I can't just leave it in pi because I have to subtract the 2. So I get 176.71. That's the area of the circle. Now I'm simply going to just subtract those two. So 330 minus 176.71 and get 153.29. And what was it? It was inches squared. Final answer. Similar concept here. We need to find the area of the circle and the area of the triangle, and then therefore subtract 2 out. Now, this one it can be left up to interpretation. It looks like 16 is supposed to be the radius on this one because notice they have it kind of off to the one side. Normally, if it was going to be the diameter, you'd expect it to be written here, kind of in the middle, as like the 6 was on number 1. So we're going to go with that this is 16. Well, if this is 16, then so is this. So the base and height of the triangle are 16 each. All right? So, again, we're going to find the area of the circle, and that's going to be pi r squared. So 16 squared, which is 256, times pi is 804.25. It's 247, so we round up to 25. Okay, so there's that. Now, area of the triangle, remember, is 1/2 base times height. Well, here it's 16 and 16. So we said before 16 squared was 256. So 256 divided by 2 is 128. So if we subtract those 2 out, 804.25 minus 128, we get 676.25 square meters. It's always square in this area. All right. No more review, but we need to do this. Parallel to the line y equals 2x plus 3. Well, if it's parallel, it has the exact same slope. So m is 2. And it passes through the point 0, -8. Well, that's actually a kind of a gimme there, because 0, -8, is down here. That is the y-intercept. So my y-intercept is -8. So there's really not much to do with this problem. Y equals 2x minus 8. You're done. Now, if this was 1, -8, well then, we would start off with our basic formula, and we would plug in the -8 here, we'd plug in the 2 here, we would plug in the 1 there, and then solve for b, and then have our equation. But we don't have to do all that work because we recognize that this was a y-intercept right here. Now, perpendicular. Well, first off, we need to find the slope here. It's -5. And then remember that the slope is opposite and reciprocal, 1/5. Okay? Now, what that means is we have a slope, we have a point, so we write y equals mx plus b. We put the -3 here, we put the m here, and we put the x here. And we're going to solve for b. So this is -3 equals -1/5 plus b. We need to add 1/5 to the other side, both sides. And that's going to give us b equals, okay, -2 4/5. Okay, because we're adding it. So it's not going to be -3 1/5. We're going the other direction. Well, we have our b, we have our m, we're done. Y equals 1/5 x minus 2 4/5. All right, now we're getting into the new stuff, which is surface area, which is the outer covering, and volume, the inside of cones, which we already discussed this shape. So here's the formula for surface area. Pi r squared, look familiar? That's the area of the circle. In other words, that's the area of the base. Remember the previous formula? We used a capital B, area of the base. There you go. Pi r squared is the area of the base. Pi rl is this part right here. So here's my pi r squared, and here's my pi rl. And that's the rest of the cone. Okay? If you think about a waffle cone, the whole top is a circle, where there's actually nothing there, but the waffle itself is the pi rl. Okay? Now, r is obviously the radius. What's this L? It's the slant height right here. We've been talking about the true height down to the bottom, but this is the slant height. So, given the formula, again, I really highly suggest you write the formula out first. So, pi r squared plus pi rl. And then fill stuff in. So, pi 4 squared plus pi 4 times 6. And now you're just crunching numbers. So you have 16 pi plus 24 pi, which is 40 pi. Again, that's the exact answer in this area, so it's squared. But if we multiply it out, we get 125.66 inches squared. Same answer, one exact, one rounded. Again, common misconception. People think the exact answer is the decimal. No, because it's rounded. It's not exact. Now, volume. Here's that capital V I was talking about. Volume of a cone is 1/3 base times height, area of the base, or 1/3 pi r squared. Remember, this right here we just talked about is that. Same formula. So area of the base is pi r squared, the circle part, times the height and divide by 3. That's all you're doing. Now notice, we're always looking for, well, it's a long line, but we're also always looking for a right angle. Whether it's there, or if it's right in the middle, it's the line that forms a right angle with the base. So one of these slanted cones, it's okay. We can still use that line 4.5. So again, let's write the formula out first. Volume equals 1/3 pi r squared h. So 1/3, we got our pi. Our radius, notice here, is 2.2. So 2.2 squared. And our height, our true height, is 4.5. If we multiply that out, we get 7.26 pi, exact answer. And if we multiply those two, we get 22.81. Both of these are centimeters squared. Okay, similar. Cone A and cone B are similar. Find the volume of cone B. We've already done a problem like this in the previous lesson. Okay, so it's going to be a similar concept, no pun intended, with this one. So, let's talk about the scale factor first. And we're going to do B over A. It doesn't matter which direction you go as long as you're consistent. Okay? So let's look at the radius first. So the radius of B is 9, and the radius of A is 3. So that's a 3-to-1 ratio. Okay? Now, we know the volume of the small one, right here. So now we're going to talk about volume. Again, we're doing B over A. The volume of B, we don't know. The volume of A, we do know, 15 pi, equals 3, that's the ratio, but remember, this is volume, so it's cubic. So what we have is the area, the volume of B, I was thinking about the capital B, over 15 pi, equals 3 times 3 times 3 over 1. Now you just cross multiply and divide, which is basically just going to be 27 times 15 pi. And that gives us 405 pi. And that's going to be cubic feet. And if we want to multiply that out, it's simply 405 times the pi key. And that gives us 1272.345, so 35 rounded, cubic feet. All right? So remember, when we're talking about ratios, volume is cubic and area is squared. Now, composite, remember that just means putting two things together. So first on the bottom, I have a cylinder. And on top I have a cone. So I'm just going to put the two together. That's all I'm doing. So remember, the volume of the cylinder, and I'm just going to I like to put little shapes here to remind myself, is pi r squared h. Okay? And the volume of the cone, and you can write the words if you want, is 1/3 pi r squared h. All right? And then I'm just going to combine those two. So let's just do them separately. So for the cylinder, portable cylinder, it's pi r squared and h. And that's the height of that cylinder right there. So 6 times 6 is 36, times 5 is 180 pi. Now the volume of the cone, again, is 1/3 pi. Now the radius is still going to be 6 squared. And then h is going to be 4. So in this one, 6 times 6 is 36, times 4 divided by 3 gives me 48 pi. Now all I have to do is combine them. And that gives me 228 pi meters cubed. And if I want to multiply that out, I get 716.28 meters cubed. And that's the composite combined figure. That's it.